All right, let's look at the directions of what direction these magnetic forces will go. And to do that, we need to do something called right-hand rule number 2. If you have not understood right-hand rule number 1, please make sure that you go back and watch that one first because it explains the first 2 of the 3 components for the right-hand rules. All right, right-hand rule number 2. What this does is it helps us determine the directions of current, a secondary magnetic field, and the force between them. So the force between fields. If you have not watched and understand the idea of this equation, F equals BIL, please make sure that you go back and watch that one before continuing in this video. What this equation gives us is where the 2 magnetic fields are from. So, a magnetic force is created between the interactions of 2 magnetic fields. B is the first magnetic field, and IL together is the second. This second magnetic field is specifically electromagnetic. The current's direction through the wire is what determines the direction of the electromagnetic field. And then, of course, where the north and the south are is what determines the direction of the permanent first magnetic field. So over here is a picture of a right-hand rule number 2. The direction of the first magnetic field, why don't we do the electromagnet, and so current. And so here we go. So just like in right-hand rule number 1, which if you have not done, please make sure you go and look. The thumb is in the direction of current. The second magnetic field is going to be from B. Remember, this is not the magnetic field created by the current. This is a second magnetic field. That's why I'm doing this in the same color scheme as what I did with the equation with F-bil up here. Okay, the second magnetic field is your fingers. And this is the direction, and I'm actually going to put of second magnetic field. And then your palm is that force. So you slap or high five in the direction of the force. So let's see what this looks like in real life with our right-hand rule. All right, right-hand rule number 2. So as stated, your thumb is current and that's the same as in right-hand rule number 1. Thumb is always current. Your fingers are always going to be the magnetic field. Again, just like in right-hand rule number 1, fingers are magnetic field. This time we have a force, and the force is coming from the palm of our hand. And so what you should notice, this is a right angle. And then going out of our palm is another line, which is also a right angle. And then from the fingers, right angle. Everything is at a right angle. Everything is perpendicular to each other. So this one, though, what's different is instead of the electromagnetic field, this B is actually a permanent magnetic field or a second magnetic field. So whenever we're talking about magnetic forces, just like I said earlier, there's always two magnetic fields that interact to create a force. So one of them comes from the current, that's your electromagnetic field, and then the other comes from the permanent magnet, the permanent magnetic field. And those two interact with a force. So the reason why it's called the slap rule is because it's kind of like a high five. The force is in the direction of your hand. And so the force would be going towards the screen. The force would be going away from the screen. The force would be going that direction, this direction. So in the direction of your palm. Let's do some examples. What if we had a magnetic field that's going north and about a current going west? Never eat soggy waffles, right? There we go. Never eat soggy waffles. All right, here we go. Right-hand rule number 2. We need current going in that direction. We need magnetic field going this. Oh, look there. Magnetic field is, in fact, going that way. And which way is my palm? Well, I will slap into the board. And so the force is going in to the board. The symbol for in is that X. So this is force. Let's do another one. Okay. What if I give you the force? How about this is force and this is current, and I want to know what direction is the magnetic field going. All right, well, force, right-hand rule, force, I need to slap this way, right? High five. Current, I need to go down. Whoosh. And so which way are my fingers going? My fingers are coming out of the board. So out of the board. The symbol for out is a dot. There we go. Now, your givens are not always going to be the two arrows. Okay, it's not always going to be north, south, east, and west. So let's do another one. right-hand rule. This time we need current to go in, like so, and we need F to go that way. Oh, well, my hand right now has the F going this way. It's going the wrong direction, isn't it? Okay. Let me flip over on this side then. N. Ah, there we go. So see, now my force, I'm going to slap in this direction. My thumb is going into the board, so which way are my fingers going? Fingers are going downward to the south. And so the answer for this one would be south. Notice every time, FBI, FBI, FBI. All right, one more. How about and there we go. So we now have the magnetic field that is going out. We have the force that is going east. So which way is the current going to go? Now, hopefully after having done all of these examples, you should notice that there is always two arrows and a circle. Those two arrows always make a right angle. And we said right angle, and then right angle, all right angles. All right. So that means our answer here is either going to be south or north, because it has to make a right angle with this force arrow. And see which one it is. Okay, here we go. Right hand rule. We need force to go this way. But I need my fingers to go outward. And so, which way is my thumb going? It's going north. And so our answer is I, going north. And that is right-hand rule number 2. Always remember, to get the right answer, you have to use the right hand. Or you could also say, the right hand is the right hand to get the right answer.